Hello and welcome. Here we have one more problem to solve, and this is also an example of free undamped oscillation. That means mechanical energy conservation is allowed here. And the problem says that we have a solid homogeneous cylinder of mass m and radius r, hinged at the bottom, performs small oscillations under the action of two horizontally identical light springs. You can see them in the picture. The spring constant of each of which is equal to k. The springs are attached to the top point of the cylinder and are unstretched in the equilibrium position of the cylinder. That means initially at t equals 0. This is the condition. Determine the angular frequency of small oscillations of the cylinder. You will definitely like to solve this problem using the dynamic method in the lab inertial frame, because things are simple. And I have drawn a picture. You can see here. Here is one called x-axis, and it is horizontally, and its origin corresponds to the position of the cylinder hinge point. And we are now going to consider the cylinder to be a rigid body, and you can see four forces act on it: the force of gravity mg, the elastic forces from the two springs, that is 2kx if it is displaced by a distance x towards right, and also the reaction force of the support that is not shown in the figure. And we have neglected the friction forces, and we also considered that the springs are massless and their deformations are small enough, quite small. So if you like, you can write the equations of moments, that is torque equation for the cylinder relative to the axis passing through the point of its hinge here. And you can see here that force of gravity is producing some kind of torque here, and the torque is clockwise, so you can write the torque of the friction force like mg multiplied by moment arm, that is r sine alpha. R sine alpha is the radius, it is the center, and this angle is alpha, so you can write its moment arm as m r sine alpha, and the torque is clockwise. Then you can see you can write the torque of elastic forces, and it is it is anti-clockwise. Important thing is this, and so it should be given a minus sign here, and the force is 2kx, and its moment of inertia I simply took as 2r, because r is small enough I am considering, and since r is small enough, sine alpha can also be approximated to alpha. So the whole thing can be simply written as mgr alpha minus 4kx multiplied by r equal to moment of inertia about the respective axis multiplied by d2 alpha by dt square. This is just angular acceleration. And if you see, we have a equation of kinematic connection. The equation that connects the coordinate of the point of attachment of the springs to the cylinder and the angle of its rotation. And this is nothing but you can write here simply x. as 2r alpha. X is small, and so the alpha is, so we can write here x equals 2r alpha. And also the moment of inertia here is about this axis, can be written as using parallel axis theorem by mr square by 2 plus mr square, and that you will get 3 by 2 mr square, and we have all the information now, and we can put all these things into this equation, and we will get nothing but we will get something like we can put the value of axi, and we can get the value, we get the equation, we can put the values, and we can get the equation for angular acceleration of the cylinder as d2 alpha by dt square. And I have done this problem before, so I know it can be written in like this: alpha equal to 0, and from here you can see that the south angular frequency of natural undamped oscillation, that will be equal to omega equals under root 2 by 3 8k by m minus g by r. And you can also see here that this result, the obtained expression for the oscillation frequency, is valid only when 8k by m is greater than g by r. You know why? Because this is a quantity under a square root, and it must be positive. And what happens if 8k by m is less than equal to g by r, less than or equal to both? Then you can say that the vertical equilibrium state is unstable, and oscillations in the system do not occur. That's simple, and it was a simple example though. Thank you very much for watching.